Right, good morning, ladies and gentlemen. Settle down, please, and thank you all for coming out on such a drizzly day. Before we get started, you've had a lecture, you've had a lab, and you've had a weekend, and you have had a chance to think about things. So I'll take a little bit of time to talk first about enrollment, which you are not going to like, and then we are going to take a few sort of administrative questions that you might have, and then we'll get going. So enrollment, guys, strictly by Cal Central. In a class this size, I cannot do anything individually, so just keep watching those waiting lists. A number of you are saying it looks open, that when I get to add, it doesn't add me. I think it adds you to a waiting list anyway, and sweeps the waiting list in at certain fixed times of the day. So you don't automatically get into an open spot. Don't ask me why. I am not a Cal Central expert. And I might even be describing this wrongly. But you have to just keep watching those waiting lists. We are not switching anybody between sections or anything. That needs to be, just keep an eye on things, and let's see how things pan out. We have not taught this course at this size in a spring semester before, so I don't have good estimates of what the movement in and out is going to be. We'll have a better sense by the end of this week, but even then, predictions are going to be pretty hard to make. So I'm sorry, that's not the kind of information that you want to hear, but that's the reality. What I'd like to do is I'd like to take just a few questions about policies, administration, this, that, and the other. Please, not very particular to your own situation. Anybody? Okay, so I would like to now offer you my heartfelt thanks. I asked this question. There's, hundreds of people in this room. And did you notice a hand go up? I did not notice a hand go up. I love that this class is not freaking itself out about minutiae to do with policies. It's going to be fine. Thank you for recognizing that. All right, now we can get to work. So we get to work always with the title side of the lecture. Today we are going to analyze some tables of data. Every lecture starts with me not being able to move to the next slide. And the announcements are always here. They're at the top of the class homepage. Homework 1 is due Thursday, but if you turn it in on Wednesday, you get an extra point. Attendance credit starts this week. I'll have more to say about that later. You shouldn't be worrying too much about attendance. And Homework 1 contains a special element. Homework 1 contains a welcome survey. We want to find out a little bit about who you are. Please do fill out that welcome survey, and it says it's mandatory. Vasilis, could you explain to me exactly what mandatory means in this case? Anybody? Staff? Okay. It's mandatory, which means we're just going to bug you until you fill it in. Fill it in, please. It's quick. We just want to know, who you are, what your goals are. This is a very diverse group, and so we want to get a sense of the distribution, and hopefully within a week or two, I will be able to give you a little sense of who you are. Right. So announcements are not a big deal. It's just going over what there is in any particular week. So the goal today is to, now that we have developed the main terminology and so on of treatments and effects and outcomes, to actually start analyzing some data. And you have started doing that already in your lab using Python. And as a programming language, there are many. There's C, there is Java, there are various other languages, then there are systems like R and so on. And it doesn't really matter if you don't know what all those different things mean. You just know, I'm sure, that there are multiple different ones of these. And Python is popular for data science as well as for software development, which is one of the reasons we chose it. We didn't want you to be restricted to something that is, typically used only for data analysis, right? So if you know a little bit of Python, you can do quite a bit of other things as well. So it's a language like any other language, and so you have to, in the beginning, there is a little learning curve for people. I mean, you remember when you were trying to learn a language that was not naturally spoken at home, then there was a little, there were hiccups. Yeah, you didn't quite know how to say something. You had to think about it. And the same thing is going to happen here. Let me give you a little sense of the flow of this class, what happens in the different weeks, and how different students respond. So for the next 3 weeks or so, we will be introducing you to Python, and we will be, blending the Python with data analysis throughout. And it will, for many of you, seem new, and you will not be able to, nor are you expected to, remember details of the language just coming out of lecture. When you start writing your code, and you should start writing because you can no more learn programming by, watching somebody else program than you can learn cooking by watching somebody else cook. Once you start working on it, have a reference like the lecture slides or the textbook or something open in front of you, and pay attention to detail like this, and then over time you will need less references. You will need fewer references. You will just be able to do things. The thing you should not worry about making mistakes. The notebooks are set up so that if you mess up, it's fine. What you've done before has not been affected, so that's fine. We're going to mess up all the time here. Nothing bad happens. At first, it feels like something new is coming at you every single day, and you're going to have to remember all these different programming methods. But what happens is by about the middle of the term, maybe slightly earlier than that, we've kind of done the programming that we're going to need. And then the rest of it is just using it over and over again in a variety of situations, adding more complexity to the models behind the data that we are studying. And so while in the beginning it might feel like you're drinking out of a fire hydrant, starting at the second half of the course, it just goes, oh, I know how to do this. And by the end, everybody's pretty much in the same place. So you should expect that rates of learning and so on are going to be quite different in the early weeks. We expect that, and it's really totally normal. It's all going to even out at the end. And as I said, you actually learn through doing. Watching is great. It's a good start, but you have to get your hands dirty. So this link you will have seen in your first lab. That's where the notebook that I'm going to use today is posted on your on the class website. When you click on that, it'll take you to that link, so you can follow along, either here or later. Okay. Let's do a little work. Python, you have used it as a calculator. We did this last time. Yes, this is a cell you enter. That is called an expression. It is just anything that has a value. And you enter that, and you run the cell, which you know how to do from lab, and the thing Python can add. It can, if I type correctly, this will happen all the time, subtract. Multiply, divide, take a look at that. A different kind of number, not everything's a whole number. It can raise to a power. And if you want to remind yourself of something, you can write a comment in a cell. It starts with that sharp symbol, and you can write any text in there. So I will say this means 2 times 2 times 2. And that does not affect the code. It's just your notation for what was happening in there. Okay. So far, any questions? All I've done is I've used it, your Python notebook as a basic calculator. Yes?
Is the caret sign used for
is the caret sign used. So sometimes in some languages, the raising to the power would have been written as 2, and then the circumflex, the caret sign, 3, and yes, so we use double stars. And this is one of the reasons when I was learning Python, after having done many years of R, I was getting things wrong in both languages. So those of you who have used calculators where you can type in, instead of pressing the exponentiation button, we can actually type in a symbol, you'll have to be careful in the beginning. Okay, but Python is much more than just a basic calculator. And you saw in lab, I think, that you can assign names to expressions. So there is an assignment statement. The action starts on the right-hand side, not on the left. This number, 24 times 7, which is what? 168. That gets computed, and it is assigned to the name hours per week. So the name is on the left-hand side. You get to choose the name. Please choose a name that reminds you of what is going on. Okay? And on the right-hand side, you have any expression at all. So this is not an equation that you are solving for. It just says take that expression, 24 times 7, and give it the name, assign it to the name hours per week. When you next type in hours per week, you will get the value of 24 times 7. That's all it is. And so if we go through, again, this is all part of last time's lab. If I go through and I assign the number 10 a name, so then what happened as a result of that cell is not nothing, but that A got bound to the number 10. So then when I type A, I get 10 back. So if I have B equals 6, you can write more than one line in a single cell, and I want to know what B is. Well, it's 6. You can then use these letters to do these names, to do arithmetic. A plus B is 16. You can change what a name is bound to. And so just to make sure that that change occurred, B is now 7. And here's a question for you. What, at this point, is A plus B? Talk to your neighbor. Right, ladies and gentlemen. Right here where my arrow is, I can see that the value of B is 7. Agreed? What is the value of A? 10. What is the value of A plus B? Right there. Okay, so there are two natural choices. Yes? 16 and 17. You agree? Okay, hands for 16. Okay, 1, 2, 3, 4. Okay, hands for 17. Okay, so this is why we don't do mathematics or computing or science by majority vote. And so let's see what happened. You've used a spreadsheet. Yes? Excel. If you go down a spreadsheet in Excel and you're using a cell somewhere else, and then you change the value of that cell, it goes back and corrects everything, right? Changes everything above. Python Notebook will not do that. That is no. That is the value of a plus b after that cell. At that point, a plus b is still 16. You have to run the code again for a plus b to be 17. Yes? So Python's notebooks work sequentially downwards. If you change a variable and you have used it previously, and you want that new name to be assigned depending on the new value of the variable, you have to rerun your cell from before. It will not automatically do it. Good? So that is something to keep in mind. It is very different from Excel in this way, and after a while you will get totally used to it. The thing with Python notebooks is to try not to go back. All right, just do things linearly. Sometimes you can just copy-paste an entire cell and run it again below. But try not to go back and forth, sort of cycle around your cells. Just think of it as a linear progression. Okay, so you're not going to be wanting to do 10 plus 7 on a computer. What I'd like to do is just see how, in a very simple example, how you keep track of what you are doing so that when you come back to a notebook later, you have some sense of what is going on. So what I'm going to do is I'm going to look at the hours people work and how much they get paid for it. And we will start with 40 hours a week. That is the typical full-time working week. So I will call it hours per week. I think, that we use the underscore to represent spaces. So hours per week is 40 weeks in year. I'm just going to say 52, and I'm going to pretend that I'm a person who works 52 weeks of the year, no Thanksgiving, no July 4th, no nothing, right? I'm just going to work 40 hours every single week, then total. How do I figure out the total number of hours? I multiply, and so and at this point, a number of you will have noticed that I'm typing a lot more than 40 times 52. Right? Would have gone a lot easier if I just typed 40 times 52. The reason I am doing this is when I come back to this notebook later, I will know what was in my mind when I was doing that. All right? So sometimes it is better, actually, to do the extra work of naming things beforehand for future reference. And so, okay, if I run this cell, what will I see? Anybody? If I just run that cell, what will I see? Yeah. I won't see anything. Let's check that happens. I got a name error. I do see something. Okay, what did I mess up? Didn't run the previous cell. That's what happened. Okay. You see the messing up? Yep. Not a problem. It's going to keep happening. We're going to mistype. We're going to forget that we haven't done something. Just keep going. No problem. Okay. So now, if I run that, I do get nothing. And in order to see total hours, what do I have to do? Just invoke its name. Okay. So that's how many working hours I'm looking at in this week. And what we're going to do now is we're going to note the California minimum wage, and in 2018 that is $10.50. And one of the things I'm noticing in this name is that it is not telling me minimum wage per when, days, weeks, months, what, and of course this is the hourly minimum wage, so you can adjust your name. And so if this person works basically every available hour at minimum wage, they will make less than $22,000 in the year. What keep in mind when you see people working at minimum wage? You can work yourself to the bone, and that's how much money you are going to make. All right, so you are now perfectly well aware of how to do arithmetic and how to essentially name your variables. This is what in math we used to call x, y, and z. And we used to use those short letters y because we were doing stuff on pencil. And it was a pain to write California hourly minimum wage equals to, but we could have in math as well. I urge you to get rid of that math mindset of calling everything x and y and actually give it an English name so that you can figure out what was going on. All right, so we have names. Something else you did in lab was you used functions, which are also called, and you ended up having what are called call expressions. Okay, so here is some math style notation, but you remember that in your lab, you had some functions like absolute value or maximum or something. So you have the name of a function, and you call that function on what is called an argument. Again, all of these words come from mathematics. And so if f is the function that takes whatever its argument is and divides by 3, then when I do f of 27, I will get back 9. So basically that is an action that it will perform, and this is an expression that has that value. And we say we are calling f on 27. Functions can have... Actually, let me pause for a second. Questions? You've done this. It's just a little summary of what you did. Okay, some functions have more than one argument. There are also different kinds of arguments, which we'll discuss a little bit later. So this function max, of course, has 2 arguments. Again, you have what function to call, you have the first argument, and you have the second argument. It matters which one. In the case of max, of course, you'll get the same answer no matter which order you put them in. But for most functions, it matters the sequence in which you enter the arguments. So as you learn to use a function, one thing to pay attention to is what is the right sequence of the arguments. And as we work today, you will see more examples of that. Okay. So let's go back to our demo. I think you have used absolute value, yes? So abs is the name of that function. How do you know what the names are? There are ways to read documentation and so on. Mostly your labs will tell you, and as you get more confident, you will be able to look around for functions. By the way, Google is your friend. All right. So if I do abs of -5, I get 5. So let me remind myself, what was A again? A was 10. What was B? I forget. We changed B. Okay. How about we do abs of, so it doesn't have to be a number. What should that be? 3. Okay. You've got max, you can do min. Okay, so here's one. Here's a number. Fine, so that's any number, and it's carrying an awful lot of decimal places. Often you want to round this number. So a round is a function. So now I need to do round parentheses of that thing to round that. You can highlight this and type a paren. This better work. It didn't work because I didn't do the paren. Let me try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. If I highlight it and just type the left-hand paren, it does the paren for you. That saves a lot of time when the expression inside here is long. And then if I type round, I am calling the function round on this argument, and I get 123, because 123.45 has been rounded to 123 to the nearest integer. Okay, so this is the default behavior of round. This is what round does if you give it only the basic arguments that it requires. And what it requires is one number. Okay. But you could say, okay, but I want it rounded to 3 decimal places. If you want that, you can put in what is called an optional argument. And in the case of round, that is the second argument. Arguments are separated by commas typically. So there's that number, and I'm going to put in 3 because I want it rounded to 3 decimal places. So I go 3 like that. And actually, you know what? I'm in a notebook. Let me just do this again. So you can compare. And now you have the number rounded to 3 decimal places. So there is a difference between the argument 1, 2, 3, etc., and the argument 3. Round does need a number to round, so you have to give it some number. It's up to you whether you want to say, okay, do more than just round to the nearest integer. Good? So arguments are of different kinds, typically separated by commas. Okay. So far, so good? Seeming consistent with what you did in lab? All right. It's time to start analyzing some data. And, okay, I ask you not to do anything at this moment. I am going to start with tables and use a very tiny little table to explain some moves to you. You will see us doing this over and over again. We will use a small little table to show you the operation so that you can see the entire table being dealt with. And then we will use those operations on much larger tables where you can't possibly see the entire table at once. Right? That way, you should be confident that you understand what is happening even in the bits that you can't see. Okay, so the point of Python in this class is for data science, and so we are going to analyze what a table is, and a table is a way of representing data, and all of you have seen tables. You've seen spreadsheets. If you go to, select a flight, then there's a whole table of flights pops up. There is the number of the flight. There's the time of the flight. There's the airport. The airport's already specified. There is the time of departure. There is the time of arrival. There is what kind of seats are available, etc., etc., etc. So a table is a sequence of labeled columns. So you just imagine looking at any spreadsheet and just imagine it's a sequence of columns, and each row represents one individual. So in the case of flights, each row would represent a particular flight, and then the row would have all the information about that flight. Each column would be something like takeoff time, right? Some attribute of those individuals. And so there is a table, and you can see that there are 3 columns. Each column has a label, which is going to be quite important because we are going to refer to the column by its label. So there are 3 columns labeled name, code, and area, square miles. Okay, what do you think the individuals are? Where do you find the individuals? They are the units on which you are measuring the attributes in every row, right? So what do you think an individual was in this table? California, Nevada, yes, but in general, I'm showing you 2 rows of a longer table. What do you think the individuals were? The states. Okay, so the individuals were the states, and for each state you have some data. You have some attributes. In this case, the name, the code, and the area. Okay, so you've got the label there. That is a column. And then there you have the Nevada row. Questions so far? All right. So let's actually look at a table. And, okay. Here is a table. As to how I got that table, don't worry about that for now. We will talk in much more detail about tables in a lecture or so, and then we will see how to read it in various different ways. But here is a table, and the person who provides you the table has to tell you what the table contains. And so I have to tell you that each row of this table, there are 6 rows, each row corresponds to an ice cream cone. And that each ice cream cone has 3 attributes. It has flavor, color, and price, and those are the 3 columns. So far, so good? Good. I am looking at 6 rows, but if I want to look at just the first 2, then I can use show. Now, look at that. You can see it's show parenthesis 2. That's just like a function call, is that not? Yep. Okay, so you can by now guess that that is saying, okay, show me the first 2 rows, but of what? Of the table. So the function calls, these function calls are called methods. The distinction is not crucial right now. But these functions are attached to tables. Right? So show me the first 2 rows, but of something. So you type in the name of that something first, and then you ask what you want done to that table. Okay. So this is just a display. What it's asking you to do is just to display the first 2 rows of the table, and there are 2 rows shown, and it tells you that there are 4 rows omitted, so that you always know how many rows there are in the table. And eventually we will show you how to just ask the Python to tell you how many rows there are without going through show. Okay, so far? Worth checking what happens if I do... Shall we do that? How about that? Should we try that? If we ask for more rows than it has, what does it do? It just gives you what it has, and then it doesn't bother with the rest. That's a reasonable thing for it to do. All right. So now you can use table methods. Show is an example of one of them. You can use table methods to create new tables from old. And one thing that we often want to do is we want to select certain columns to work with. Usually tables are huge, and we just want to focus on a couple of attributes. So rather than carry the whole thing around, we're going to want to select certain columns, and so we name the table, and we say what we want to do, which is select. And then we have to provide the name of the column. So for now, I am just going to select one column, flavor, and its name is a string that must be enclosed in single quotes or double quotes, if you like. If I do this, what I get is a new table consisting of just the column that I specified. You should be reassured that nothing bad has happened to the original table. The original table is still there. Virtually every table method that we show you will leave the original table unchanged, so you cannot mess up your basic data set. So you can work with it however you wish. The original thing will still be there. You can specify more than one column to select. So what shall we do? How about flavor and, I don't want the color. I know chocolate ice cream is typically brown. So how about we do price as well? I get another new table with these 2 columns. So now this new table that I got is, of course, the original table where I've selected these two columns. You will agree that it is also the original table without the price column. Yes? So you can also drop columns if that's faster. So cones.drop. Without the color column. If you drop color, you get exactly the same table. And as with select, you can name a bunch of columns to you can name a bunch of columns to drop. You can simply provide all of their labels separated by commas. This also leaves the original table unchanged. So I'll pause for a second. I will take questions. Every time you do this, you are creating a smaller table from the original. Original one remains as is. You can give this table a name. So it's just an expression like any other, so you can give it a name. Why don't we call it no color? And then if we just do that, then that gets assigned to no color. And so if we look at no color, then we see the table that we've seen before. Good? Yes? Very good observation. The show method was about rows. It said, show me these many rows. Right? The select method is about columns. We are now going to do another method about rows. Right? In fact, several. So there will be multiple methods about columns and multiple methods about rows, and it's like part of learning the language is to learn which one operates on which. Okay. So let me remind you of the table again. It's like that. Now, one of the things we often want to do is we want to sort by a particular variable. So if we sort this by price, let's look what happened when we do cones dot sort. Okay, sort by what? I have to say by what. So I say cones sort by price. Is the call clear? It's just the very similar to previously. You're just changing the name of the method. And so what happened here? The rows have been rearranged in increasing order of price. Yes? Sorting, increasing order is the default behavior. Sometimes, of course, you will want decreasing order. In that case, you put in an optional argument which says descending, let me spell that correctly, equals true. And why that came up in green will become clear in next lecture. But you just ask for the sorting in descending order, and you get the same table sorted in descending order. The original table has been left unchanged, yes. What if you sorted by column that doesn't have numbers in it? Let's do it. So cones.sort, how about flavor? That work? Okay, so let's see what it does. What do you think it did? Alphabetical order. All right, and if you want reverse alphabetical order, you do descending equals true. Somebody there had a question. The question went away, okay. In this case, is the individual a flavor or just ice cream? The individual is a particular cone that somebody bought. Yeah. No, okay. So could you also input decreasing? I believe not. Now, this is a language, and it's a very particular language. And so descending equals true is the argument, and we cannot say, well, what I've written is equivalent, because Python doesn't actually know English. Right? It knows the sequence of methods in exactly the characters that were given to it, and so descending equals true. Thank you for raising that point. It's a very important point. Okay? Now, as was pointed out, we have some methods for selecting columns, dropping columns. Show just displayed certain rows. What if we wanted to create a table consisting of just some of the rows? Not all of them, but some of them. then what would we do? Well, you use the where method. So supposing I want just the chocolate cones, then flavor has to be what? Chocolate. So this is the easiest. So the row has to satisfy some condition. So this needs another argument, which is the condition that it has to satisfy. This is the easiest possible condition. That is that in that flavor column, I want chocolate. So I just say, I want chocolate, like this. Good? And let's see what happens. You only get the chocolate rows. So what happened was it went through one row at a time and looked at the flavor column, and if the flavor column had chocolate in it, it included it in the new table, and if it did not include it in the new table. And, while there was a question about exactly what you can type, here is something that you might want to do. If you just said, while you are typing, you are typing, well, flavor had an uppercase F, why not chocolate with an uppercase C? And look what happens. What table did you get? You got an empty one. You got those labels and no rows. Why? Because it could not find any row in which the flavor column had what you typed in. So please type in exactly what you are searching for, and make sure that that is consistent with what's in your rows. Okay. You can do more than one operation at once, though in the beginning we ask that you perhaps try not to do that. So there's cones, and then if I sort by price, well, actually, why don't we drop color? Okay. I'm not running this. At the end of this expression will evaluate to what? What kind of object will it give me? A table, right? So that's just an ordinary table. Well, sort is a table operation, so I can now use sort on this table. So I can sort this smaller table by price. And so, you can take a table, do something to it, create another table, then do something to that, create another table, and keep going. Unless the operations are very quick, that is not recommended. Okay? Because you will not know where you have made mistakes, and later on it's very hard to read. So keep giving things names as you go along. All right. So that is, for now, a set of table methods that we know about, and I will... That's a slide that has a summary of what we've done. We know how to select columns, we know how to drop columns, we know how to sort, both ascending and descending, by the way, and we know how to find all the rows that satisfy a very simple condition. Of course, you may want rows that satisfy more complicated conditions, and those conditions will be stated in a slightly more complicated way, and we'll come to that later on. Okay, don't do this. Don't do this. Let me tell you something about attendance. Do nothing. You see this room? It's all over full. And staff were outside telling people, no, I'm sorry, it's over full, fire marshal rules, we can't get in. On days like that, here's what happens. Everybody gets credit for attendance. You have to do nothing. Because it's not fair if people are trying to get in and we're saying you can't get in, that they don't get credit for attendance. We have no way of knowing who anybody is. If the whole class is over full, then the class is here. As far as I'm concerned, everybody has got credit for attendance. So you need never worry that you will not get attendance because you were trying to get in and they told you couldn't come in, right? Under that situation, everybody will get attendance credit. So nothing to be done today. All right, so no. What I want to do is I want to go to... Okay, are we sick of ice cream cones? Yes, thank you. All right, so... How about that? So this table, NBA, represents every row. Whoa! Every row is one player in the NBA in the 2015-2016 season. Those of you who follow basketball know that there have been some changes since then. Every row represents a player. You've got the name of the player, you've got the position that the player plays in, the name of the team, and the player's salary in millions of dollars, annual salary. Okay? And so Paul Millsap was a power forward for the Atlanta Hawks, and he earned about $18.6 million in 2015-2016. Good? All right. How are we going to find Steph Curry? We are going to use the name of the table, right? Steph Curry is what, a row or a column? He's an individual, he's a row, so we're trying to identify a row, and so we're going to say, now this is where you have to remember what the column was called. Player is okay. So you couldn't see his row here because show by default, when you name a table, what you will see is the first 10 rows of the table, and the rest will not be shown. So we are seeing 10 rows, and 407 are omitted, so there are 417 players in all in this table. All right, so here is a discussion question for you. Talk among your friends and figure out how to display just the row, only one row, just the row corresponding to the player that had the highest salary that year. Go. All right. Before we start thinking about what we're going to type, let's do sort of a mental sequence for what is the thing to do. We want the player with the highest salary. Yep. So what do we have to do to the table? We have to sort it. We need to know what the high salaries were, and in what order do you think we should sort this thing? Descending order, so that the highest salary is right on top. Everybody agree? So then what do we do to that table? Just show that first row. That's what we have to do. Okay, so with that plan, will you please tell me what to type? What is the first thing I type? The name of the table, NBA, and then dot. Yes, now what? Sort by salary. It matters that you give the column label first, and descending equals true. And then show what? One row, the top row. In those days, it was the great Kobe Bryant, since retired. Good? All right, so, all right, hold up. Wednesday's lecture We'll do a little bit more data analysis. We will get into nitty-gritty types of objects in Python, how to work with them, and then we'll start working full-on with tables.